Hi, good morning and good evening, everyone. So yesterday we completed our Terraform module development, like using open source modules and creating our own modules. So you can start taking some tasks like creating EC2 instance module on your own and then push it to your GitHub. Just take it so that you will get good practice about module development. Okay. Then just 1 second. Yeah, I already provisioned our RoboShop project using Terraform. It's going on in the background. So today we will start with monitoring. Okay. So I just pushed some documentation here. So this is the monitoring concept we will discuss now, theory for a few minutes. Okay, as said earlier, monitoring is very important because whatever the technology you use in the background, if it goes down, our entire business will go down. Okay, so if there so no system is 100% perfect in this entire software industry. Every system may have some continuous errors. Even you are improving the technology, they will definitely have defects. If you're solving a defect A, then definitely defect B will come again in the future. So we have to continuously monitor our system so that our business will not go down. So that is very important part. So if you don't do monitoring, let's take two cases like this. Suppose we are not doing any monitoring. So what will happen? Someone like our customers, you can see the screen, right? This one, elk.md. Can someone please confirm again? Yeah. So the use case is you are not doing any monitoring. So then if something goes wrong in your system, what will happen? Your business customers or end customers should report to you. You have to wait until they report to you about something goes wrong. Then you go ahead and then you will check what went wrong, and you take some root cause analysis and you take some downtime. Again, you take some time to fix the defect. So this process will take a lot of time. Within that time, so your business will definitely go down and you lose the customers. Okay, so that is what happens if you don't do monitoring. But proactive monitoring is nothing but instead of you wait for someone to report. Okay, so what you do is you continuously monitor your systems, and then you will try to find the errors, try to find the downtimes, try to find the less no like less memory errors, all these things, high traffic. So there are some things we can discuss now. So proactive monitoring is instead of waiting for someone to report to you, you will go yourself and then you will continuously monitor for errors, downtimes, failures, and then you can predict also. Okay, so if a software is using high memory now, maybe 60% or 70%, but after 3-4 days it may use 100%. So then you will have the analysis why it is using high memory, and then you can stop before reaching 100%. Okay, so that is like you can have the analytics before it goes down, you can understand. Okay, so there are two types of monitoring: white box monitoring and black box monitoring. So you can just, so we always refer Google SRE. Google SRE for the standards. Okay, so you can just go and then here Google SRE monitoring. So I just got this from them. Okay, so this is the one. So here you can just go to the 6th chapter, that is monitoring the distributed systems. The definitions I took from here. So I just wrote, simply copy and paste, and we can discuss on it. So white box monitoring is nothing but what your system have, like how many servers, databases, and then logs, what are the softwares you installed, you know about your system completely. So that is white box monitoring. So white box is nothing but you know what it has. Okay, in a box, if it is white, you know what are the items the box have. So the same way, white box monitoring is nothing but you know about your system completely. How many servers, where are the logs writing, what are the packages inside, what are the tools installed. Okay, everything you know about your system, that is nothing but white box monitoring. So I know I have multiple Linux servers. Now I can monitor all these servers. That is called white box monitoring. Black box monitoring is you don't know anything about the system, what is going on. You just know this one, web.joindevops.online. Okay, so this black box monitoring is nothing but I can continuously monitor this website, and if something goes wrong, I can report to you. So this is black box monitoring. Still, it's going on. Okay, so this is black box monitoring. As a user, I don't know anything what is in the background. I know only this URL. Okay, I can monitor this URL, and if it is not giving me any response, then I can immediately inform to your team. So that is called black box monitoring. Okay, so nothing much also. It's okay. Just understand the meaning, that is enough. And then dashboard. So every monitoring we should have some dashboard so that you can easily understand what is going on in the system. Okay, so you know the dashboards, right? Like for example, if I say Himana dashboards, so you will have some dashboards like this. Okay, what is the situation now? How many users, how much traffic, how many log files, okay, how much CPU memory, how much RAM memory, everything you can search, everything you can see on the dashboard. So that is the dashboard component. Uh, it has good visibility and then graphs. And then alert component. Alert is nothing but if something goes wrong, you should get the alert. It's not only monitoring. So all of us cannot sit in front of the dashboard and we can continuously check for errors. Okay? That is not possible. The dashboard is just to give you data, but you cannot continuously see the dashboard and then find the errors. So alert is nothing but if something goes wrong, you should get automatic alerts like email alerts, Slack alerts, okay, and then some SMS, whatever it is, some automatic phone calls. Something goes wrong, you should be immediately notified. So that is the intention. Okay, so we cannot keep in front of the system and we cannot check every 5 minutes. We cannot check for the alerts. Okay, so if any alert occurs, we should get immediate notification. Okay, just like when someone uploads YouTube video, we will get the notification immediately. Okay, we cannot go to their channel and check every day. So that is the alerting mechanism. And root cause, whenever you get some alerts, okay, so there will be a procedure that is like incident. In every company there will be an incident procedure. Okay, if high alert, then we will raise incident ticket just for tracking, and then we will note down everything here, and we need to check the priority. Okay, it's like P1 high priority, P2 high priority, P3 low, P4 very low. So based on that, you will have SLA, service level agreement. P1, you should clear it within 2 hours, P2 4 hours, P3 8 hours, P4 2 days. So like this, every company will have some process. Whenever you get some alerts, you need to handle those alerts. For example, if you get P1 alert, so you should immediately go and then restore the system. So P1 is nothing but your business is going down. P2 is also going down. These two are very high alerts. P3, business is not down, but you should clear it within 1 day. P4, business is not going down and it is very low priority alert. Okay, based on the alert type, you need to immediately address the issue. So to address the issue, you need a lot of data. So that data is coming from this one, monitoring metrics. Okay, and you you will restore the system immediately, and then you will understand what happened, and you have to write a detailed analysis what went wrong, and in future how can you stop these kind of situations. So that is the root cause analysis, generally RCA. Okay, so these are the general monitoring terminology. And then we have the 4 golden signals from Google. If you are able to get this data, then you will be good at monitoring. Okay, latency. What is latency? So latency is nothing but if I send a request to web.joindevops.online, how much time it is taking to give the response. That is nothing but latency. Latency is time for responding. and for response. If latency is more, then you can say something is wrong in the system. So every customer needs fast response. If you are opening Amazon.in and then Flipkart.com, if Amazon.in is responding very fast, then obviously you will do the shopping in Amazon.in. Okay, so latency should be always low. So our intention is to make this latency very low. And then traffic, you have to calculate the traffic continuously. How many users are accessing your system? Okay. How many users are accessing our system? So you need this. For example, last time you remember AHA platform crashed because of Prabha's interview. So suddenly the traffic got increased. If you are able to monitor the traffic like every 1 minute or every 5 minutes, then you can understand the user behavior. At this minute, like 7:15 a.m., for example, if you have 1 lakh customers and 7:20 you are getting 1.5, 7:25 you are getting 2 lakhs, 7:30 you are getting 3 lakhs, then you should understand the users are accessing our platform users are accessing our platform more. So we need to be ready to increase the number of resources, number of servers, our entire infrastructure we need to increase automatically. So that is how you should monitor the traffic continuously, okay, to keep the business up and running. Just like our India-Pakistan match, if it is streamed in Hotstar, so more users obviously see the Hotstar platform. Okay? So you should always remember to monitor this traffic also. And errors, 500 error, 503 error. Okay, so these errors are critical because these errors are from the server side. So these errors are from server side. It means something is wrong from our side. We need to continuously monitor these errors and then raise alerts if you are getting more errors at particular time. Okay, for example, within 5 minutes, if you are getting 1,500 503 errors, there is something wrong in our system. So we need to immediately get alerts, and then we have to know what is happening and what is causing those errors. That is one of the thing. And then saturation is nothing but benchmark. Okay, benchmark. What is benchmark? So like we have multiple servers like T2.micro. So this is a small server. We need to understand how many users at a time can access our web.joindevops.online. Okay, how many users can access without any errors? So that is the saturation point. For example, if it is able to serve based on this resources like T2.micro, it means 1 GB RAM and then 1 CPU. So based on this resource, maybe it may serve around 50,000 or 10,000 customers. Okay, so you should understand that. So you should understand my current infrastructure can serve these many customers. If I get more customers, then this will be definitely saturated, so that I need to increase the resources. Okay, you can see this. Utilization should not be 100% all the time. Okay, you can give the utilization 80%. If your systems are reaching 80% utilization, then you should get immediate alert, and then you have to take decision, okay, to increase that. So this CPU utilization, memory utilization, everything we have to monitor. Okay, so you can read this paragraphs. Okay, so this will be good for understanding the purpose of monitoring. Okay, but whatever the summary is, this one. Okay, so to monitor all these things, we have some tool called ELK, Elastic Log Stash and Kibana. So this is originally they developed for different purpose, but it got more usage. Okay, so originally Elasticsearch is nothing but, you can understand, it is for searching mechanism. For example, if I just do Google, now if I type a word DevOps here, okay, so the search results, these are the search results automatically coming from Elasticsearch. Okay, so whenever you do a product search in Amazon.com or Flipkart.com, you will get immediate suggestions. These suggestions are from the ELK. Okay, so developers will understand what are the things customers can search, and then they will keep the data in Elasticsearch. So basically, Elasticsearch is a database. Just understand this as a database. Elasticsearch is a database. Distributed is nothing but highly available, distributed database. So you will store anything. We will store documents. We will store data like key value pairs. We will store the logs. We store everything. And over this database, we can search easily. Okay. So the distributed search engine generally for searching purpose, but later we understood the more we unleashed the more advantages, like we can store the logs, we can do the event analysis, we can do some graphs on it. So it got more usage after that. So now we are using Elasticsearch for log monitoring and then for searching purpose heavily. Okay, so that is the Elasticsearch. Just understand it's a database. So from Elasticsearch, we have other components like Logstash and then Kibana. Elasticsearch is a database. Okay, it has the data, but how can you view the data is nothing but from the Kibana. Kibana is a UI. Kibana, this is a UI that connects to the database. That connects to Elasticsearch. So just like we have databases in our RoboShop, and then how we are watching that data is from the, suppose we have categories data in MongoDB. How can we view it? We are viewing it through the web UI. So similar way, Elasticsearch is the database. You have a lot of data inside. How can you view that is through the Kibana component. Again, this is from Elasticsearch. Okay. And then one minute. Okay, Kibana is the UI, Elasticsearch is the database. And we have some component called Logstash. So Logstash is nothing but filtering. You will understand when we are installing this. So this will filter the data coming from agents generally. Okay, so our use case is our Nginx is giving lot of log files, right? So if you see, we are using Nginx logs and catalog logs, cart.logs to understand what is happening, what is going wrong. But we cannot store those logs in the Linux server for a long time. Okay, we can see. Now let me show you the data. This is our web instance. So whenever users are using our website, we are getting a lot of information. That is, we can check through the log files. You know how to check the log files also. So we have our var log Nginx and then access log. Okay, you can see we are getting a lot of data. So when our customers are using our website, we are getting a lot of data about from which IP address we are getting it and what time and what is the request our users are making, and then what is the response and from which browser they are sending the request. And then, yeah, so this is the full data we are getting. If you get some errors, you can see the status codes also. 200 means success. And if you get 503, 500, that means the error. So this is the data. So every time we cannot rely on the Linux server, because these logs will be automatically deleted after some time, and it is very difficult to analyze this much data. Okay, suppose your client will come and ask how many 500 or 503 responses we got, and what is the lengthy request today. Okay, and what is the fastest request today, how much time it will take, how much time it took already for the longest request. It means like sometimes when we are browsing, it will take a lot time, 1 minute, 2 minutes, like that. So your client may ask anything based on the business. Okay, he wants to understand the user behavior. So for that, if you are storing here inside the Linux server, you can never analyze that. So this is not the analytics engine. Really. This is just to store the log files temporarily in a Linux server. So we need some analytics engine. We need some storage of data. So that is nothing but Elasticsearch. Okay. So we will input all the data we are getting here to the Elasticsearch, and in the Elasticsearch, we will analyze that. Okay. So then who will send this data? So that agents, that is file bit generally. Okay, so these agents, file bits, can access log files, and they can ship to Elasticsearch. Okay, someone has to push these logs to the Elasticsearch continuously for our analytics purpose. So that we use, for that purpose, we use file bit as an agent. So this file bit will be accessing our access.log or nginx access.log, and this will be continuously pushing to the Elasticsearch database. And then you can view that data in the Kibana UI, and we will use Logstash for filtering. We will discuss that as well. Okay, first we will configure this one. So what we can configure is, so this is the agent, file bit agent. It is accessing access.log continuously from our Linux server, and this will push it to the Elasticsearch. Okay, and Elasticsearch is a database, and user can connect to the Kibana UI, and he can watch the data inside Kibana UI. Okay, so this is the use case. We will see that right now. Okay, and I have the installation instructions. First, so let me create one server for ELK. I'm launching one ELK server. So just try to understand these components, what we are doing. I hope it's clear. This is very simple. Agents are for collection purpose, collection agents. And this will send to generally Elasticsearch, and Logstash is also required. We will discuss that use case, why Logstash is required. Okay, agents are sending to the Elasticsearch database, and then users are connecting to the Kibana UI. So that Kibana UI is fetching the database, fetching the data from Elasticsearch. So this is the whole use case. Okay, we will implement that now. ELK, I'm taking it. Let us take our DevOps practice. And this is a huge software. Okay, ELK is very huge. So you need a bigger machine generally. T3 medium, T2 dot micro. This will not be good. Those are not enough. Okay, let me take at least 4 GB RAM, and then 2 processors. Okay, 2 CPU. This is also not enough generally. So let me take T3 dot T3 dot large. I'm taking it. Okay, T3 dot large, 8 GB RAM and 2 CPU. Don't run this instance for a long time. And storage can be at least 30 generally. Launch instance. Okay, T3 large, and then other things are same. Okay, let me keep it inside our RoboShop. Or you can keep it inside default also, not a problem. ELK. So while practicing, if you don't have a RoboShop, that's fine. Okay, you can keep it inside default VPC also. Don't worry about that. CentOS 8. E3.large. And then no key pair. And go for network settings. Select our RoboShop. And then keep it inside public. Okay, so that we need to open it. And then select allow all and 30. Okay, that's it. Since I have the RoboShop components available, I'm keeping it inside RoboShop network. If you are not running RoboShop, then you can keep it inside default network also. Okay. Let me take this IP address. Okay, now we need to configure this. So the installation instructions are here. This is very easy. Just installing Java, and then Java is required because Elasticsearch servers are developed on Java, and you need to keep this repo, and we have the installation instructions, and we have configurations. We will do that now. Okay, so now let us take the root access and then install one by one. So first install Java. You can write a shell script. You can write an Ansible playbook usually for this. And then add this repo. Let it complete. Okay, and create this repo. And then here, just paste this. And after this, just install Elasticsearch-y. Installed. So and every component from Elasticsearch, it will have one configuration file in this directory, etc, and the component name Elasticsearch, and then elasticsearch.aml. Okay, open this configuration file, and we need to uncomment few things. Okay, you can see I just wrote here, just uncomment this http dot port and then network host allow remote connections, and then keep this line under discovery section. We'll do this now. Okay, there will be, you can see this network dot host. Okay, uncomment and then give 0.0.0 so that you can open it from the internet. Otherwise, you cannot open from the internet. Okay, and then http port 9200, uncomment this, and then in a discovery section, just have one line here. I'm just keeping this line. Okay, discovery type single node. Because this is a single node, we are installing this Elasticsearch. We need to keep this line. That's it. Save. Okay. So you did the configuration, and then you restart. Okay, so either it started successfully or not, just issue this command 9200. So you will get this. Okay, so if you are getting this version, everything properly, then Elasticsearch installed successfully. Okay, this is the sample output you get, and you can enable the Elasticsearch also. So that's it. Elasticsearch is installed successfully, and we have done the configuration changes properly to allow remote connections, and then we have given the discovery type as single node because we are installing Elasticsearch in a single node. You can have it in a cluster wide environment also, but that's fine. So next we will install Kibana. Okay, all components like Elasticsearch, Logstash, and Kibana is a full suite from Elasticsearch itself. So this Kibana is connecting to Elasticsearch. Okay, Kibana is connecting to Elasticsearch. So you need to edit the Kibana configuration so that it should connect to the Elasticsearch. Okay, again, vim etc Kibana and then kibana.aml. Okay, here you will just uncomment this one 5601 and this one server.host. It should be 0.0.0. Okay, so you can read this, why this configuration here. I just made it here also. Okay, server.port, server.host, and then you have to uncomment this Elasticsearch hosts also. So it is running in the local host 9200, so that Kibana can connect to this on this, connect to Elasticsearch on this port successfully. Okay, that's it. Okay, now systemctl restart Kibana. You can just check netstat-lntp. Kibana is starting in the background. You can see 5601. 5601. It started successfully. You can always check for the logs also. Tail-f var tail-f var log Kibana and then kibana.log. Okay, you can check this. Kibana is now available. So let us open this on 5601 port. So it will open 5601 port. So this is the UI connecting to the Elasticsearch database. Okay, that's it. Okay, so now the Elasticsearch is ready and then Kibana is ready. We need to push the data from our servers. For example, we have our web server like web.joindevops.online. So this is continuously generating some log files. Okay, so what I have to do, I need to push those log files. For example, this is the web server. I need to install FileBeat agent here, and then this agent can access this access.log and it will push. First, we will push it to the Elasticsearch, and then later we will understand the importance of Logstash. Okay, so let me open this web instance. Is the font too big? Is this font too big for you? Actually, this is one of the latest monitor. Is it too big? Okay, thank you. So this is our web server. So wherever you want to monitor, you need to install FileBeat here. Okay, so to install FileBeat there, again, I need to have this repo here. So this is my web instance. So inside, okay, I am keeping this Elastic repo. So now you can install FileBeat. So FileBeat is a very lightweight component, so that is useful just to push the logs. Okay, FileBeat installation is done. Now let us open the configuration etc FileBeat and then FileBeat.aml. Okay. So you can say this FileBeat inputs. So input you have to enable true. Okay. So this is the input. This log files are nothing but the inputs. Enabled should be true. And then which log file you want to access. So now I want to access var log nginx / access.log. Okay, so this is the log file I want to ship. That's what I'm configuring here. You can ship as many log files as you want. And that is the input. And output is nothing but where you want to ship. Output, I want to ship. There will be output section. Okay, inside output section, you can see Elasticsearch. It's automatically enabled now. So I want to push to output.elasticsearch, and this is the host ID. What is our Elasticsearch host ID? I mean host IP. Just get it. So this is my Elasticsearch IP address. This one. Okay. So this is my Elasticsearch IP address. Okay. Give that private IP generally. That's it. Fine. So now let me start systemctl start FileBit. Okay. You can check the logs of FileBit tail -f var log messages. And you can see the connection is established. So now let us generate some traffic. Okay, so this is the website. I am pushing it. So now FileBit should continuously push this data to the Elasticsearch. Okay, you can see FileBit is accessing and then pushing it. So now let us go and then check in our Elasticsearch. This is the Elasticsearch homepage. And to check the data, just go here and then stack management. So there will be index management. And here you can see we got 52 lines from our Nginx. Okay, you can just check cat etc, sorry, var log Nginx access.log. What is the word count? You can see 52 records are here, 52 lines are here. You can check the same number of lines are exported to this. Okay, so how can I visit? How can I view that? Just you have to go to index patterns here, index patterns, create index pattern, give that name FileBit, and then timestamp, select this timestamp, create index pattern. Okay, so data is there. Just you can see the from the index management. Now you have to create the index, create it. Okay, index pattern is created. So now you have to go in the menu again, discover. Here the data will come. Okay, now you can see 52 hits. So this is the full data. This is the full data of your 52 records from the access.log. You can just open it. Okay. So open, and then you can see this is the message, right? So this is the IP address user accessed at this timestamp, and this is the method. So this is the URL, and this is the response, and yeah, so this is the agent. So this is the general data from the Nginx server. Now you can keep on using this, and then you can just check and add to the cart. Cart is added. Check out Australia, Sydney, calculate, confirm, pay now. Okay. So a user in the front end, they placed an order in your website. Now you can just see the data here. You can see we got 72 hits. Now you can check each and every line what happened. Okay. Now you can check. This is the message. So user hit post. This is the API. This is the payment API. And then we got the response 200. And this is the IP address. We are getting full information. But if you see, so this is the unstructured data here. You can check, you can see this is the unstructured data. How can I, and this is the structured data. This is key. So this is value. If you have structured data, it is very easy for you to have some sorting. For example, now I can have this as column. You can just check toggle column in the table. So I can have this as column. This is the table. This is the key. This is the value. But this data we are getting, it is completely unstructured. So what is the structured data? Key and value. So what is the structured data for here is, this is the unstructured data. And if you want to keep it like that in a structured format, this is the client. If I get like this, then you can do the analytics. And this is the time. So this is the method host. And then this is the URL. Is the URL accessed. So if you get like this, then based on this key value pairs, you can analyze the data very easily. But if you get the data like this to your Elasticsearch cluster, you can just see, but you cannot analyze it properly. So that is where we need Logstash component to filter the data. Okay, you can see. So now FileBit, instead of sending it to the Elasticsearch, if you send it to the Logstash component, it will take the data and it will filter it, and then it will reformat it into the structured data, and then it will push to the Elasticsearch. So that is why we want Logstash component in the middle to format and filter the data. Okay. So yeah. So we have a lot of applications. Every developer writes their own log files in their own format. So Logstash can keep the filter and format it into the format we require for analytics purpose. Okay. So we cannot ask developers to write in a particular format generally. So they will write it in the format however they want, the log files. Okay. So but Logstash here you can always filter and format the data in your required format and then push it to the Elasticsearch. So that is the advantage of Logstash. Okay, you can just see it's a data collection and processing tool. It will process the data. It will take input from any source. It will filter it and then output to the Elasticsearch. Okay. So now I said one important metrics, that is nothing but latency. You want to know how much time for one request. So that is nothing but latency. So latency, I want to calculate how much time it is taking when a user hit. So this one, when a user hit URL in the browser, I want to understand how much time it is taking to load the complete response. So that is nothing but there is a thing called Nginx response time. If you see this, so there will be thing called request. You can see request time is a variable. Nginx is storing the time taken, starting when Nginx reads the first byte from the client and ending when the Nginx sends the last byte from as a response. Okay. So this variable Nginx is storing the complete time taken for one request. So now you need to add this. So here for now, I'm just stopping it. Systemctl stop Nginx. Okay. And let me open that Nginx configuration, VM etc Nginx default.t and VM Nginx. There is nginx.conf. So here you can see there is a log format. Okay, so this is the log format. Okay, this is the log format. So it is storing the remote address first and then remote user next, and then what is the time, what is the request status, bytes, how many bytes it sent, who is referring this. So everything it is here. So I want to add the request time also. Now if I add this one, request time, I will get the time also logged inside the request. Okay. So here, let me compare. Okay, so this is the IP address and hyphen, and this is the user. User is not logged here. That is why it is space. And this is the time local, this one. And this is the request post, and then post and status. Status is this one. So this request is nothing but this one, full from here to here. Okay. And then, so this is the status. What is the status? 200 response. And how many bytes it sent? 51 bytes. And this is the referrer, HTTP referrer. And this is the agent. This is the user agent, Chrome browser. And HTTPX forwarded for. This is blank. And now I want time also here, like 2 seconds or something, like 3 seconds or 0.4 seconds, like that. So that is why I added request time. So now we can remove some unnecessary things. So this remote user anyhow, it is not useful. So I'm adding remote address and then time. Just we can remove this also. And status, I want status. And I don't want bodies, referrer, user agent, and then I want this request time. This is the information only I want. Okay, I don't want any other information. So I'll keep this also in the document. I'll update this. Okay, remote address, time local, request, status, and how much time. So that's it I want. So here, edit carefully. After name, so you need to just copy paste. And this semicolon is very important. Okay, the semicolon is very important here. That's it. Okay, now you restart systemctl, restart nginx. Now let us check that log file. Let me generate some traffic. Now cat var log nginx access.log. Now you can see the time also here, 0.00 and then 0.015 seconds and 404 for ratings. So you are getting the time also. Now you can see this is the IP address, this is the timestamp, this is the method, and this is the URL, and this is the status, this is the time taken for the request. Okay. So now we are pushing this. And go and just check here. You will see the message has the timing also. Okay. So now I want to make it into a proper format, structured format, like key value pair, key value pair. Okay. So for that purpose, I need to configure logstash. Okay. So in the same ELK mission, so this is the ELK mission. Yum install logstash. Okay. So let me stop FileBit for now. Systemctl stop FileBit. Okay. So here I'm installing logstash. Okay, and there's the configuration VM etc logstash conf.t. Inside that I'm creating one configuration. So here we need to just mention what are the inputs and outputs. Okay, so this is the input. I'm taking it from the 5044 beats. So input is coming from this port number. Okay, and then here Elasticsearch output is sending to the Elasticsearch. So here you should just give the IP address. Okay, it is in the same. It is in the same server. Okay, Elasticsearch, Logstash, Kibana are in the same server, so localhost is enough. This is the Logstash configuration, and then yeah, you can restart, and you can enable. So now let us just see the file bit. Okay. So earlier we are sending the output to the Elasticsearch. Now we have Logstash, so I'm just commenting this. Okay, I'm commenting this Elasticsearch, and then I'm uncommenting this Logstash. Okay. So this is the Logstash is on 5044. This is the IP address. Okay. So now instead of directly sending into the Elasticsearch, and I'm just pushing it to the Logstash so that it will do some filtering. Okay. So now let us restart Logstash. Sorry, restart FileBit. Now you can check the messages. Log messages. Okay, connection is established. Now let us generate some traffic here. Okay, it is sending it to the Logstash, and this Logstash is pushing to the Elasticsearch. So that is the input and output. Okay, so now just let us refresh. Okay, we got the latest data. Okay, just let me do something. Now it is 8:3:41. We need to get the latest time. Okay, 8:4:39. 8:4:43. So we are getting the data. Okay, you can see this. Now the data flow is different. Just understand this. Now the data is from the file bit is sending to the Logstash, and Logstash is sending to the Elasticsearch. Now we don't have filters as of now. Now I'm going to create the filters. So why we need filters? Just understand again, because this format we cannot do any analytics. This is the raw format. This is the raw format. I want this as a field. I want this as a field like this. A client dot IP address, client is IP address, and this is the timestamp, this is the method. So I want a fields like this. So for that purpose, we need to have some filters. Logstash filters. This is the filter. Here you can go and check. So there is a filter called grok. So we can have a lot of filters generally. The Logstash is a very big thing. Okay, and Elasticsearch is also very big. So we don't use it for other purposes. We are using for only monitoring purpose. That is our responsibility, not to use for searching functionality. Okay, just go to the grok. So this is the filter plugin. So here they will give us clear documentation. How can you use this? Okay, so this is the format we are getting. If you want to filter, you need to give like this. Okay, you can see this is our input generally coming from feed, and this is the filter. So you have to add in between. So generally, so let me take this. This is the filter. Okay, so this pattern, how you need to write filter, it's nothing but you will give your key, this one message, and then this is the IP address. So this IP address, they are naming it as a client. So this value, okay, let me take this. So this is the data generally, and this is the filter. This is a simple syntax, just understand this. So Logstash is getting this value into the IP. This is the key. Now inside your Elasticsearch, this is how it is going to store. Okay, so this is the input, and this is the key, and this one word. This is the standard thing. You have to just get it from the Logstash website. Okay, and now here it will store method, that is get. Okay, and here it will store request, that is /index.html. So these things, left side things, we need to get it from the Logstash. Okay, and this is number. It will store bytes into this one, and this will store duration. Duration is this one. So like this, we will have the data inside our Elasticsearch. So now it is very easy to sort and then to filter, to search for everything. Okay, so but these patterns on the left side words, we need to obviously get it from the this one, Logstash grok. So there will be a documentation here. You can just see the GitHub, and we can also have something like grok pattern generator. So this is the grok pattern generator. grokdebugger.com. So here, let us give our format. So this is the format. This is the format. Okay. Here you can generate the grok pattern. You can have something like pattern repository. What is the pattern? It is first percentile, and then this is the IP address anyhow. How I know this IP? So I have to refer grok. Now you can see. So this is how it is going to store. And then we have space, and again dollar braces. Okay. And what is this? What is this? Actually, on the left side, you can just go here and there will be grok patterns. So this is HTTP server, right? So there will be HTTP date. Yeah, so this is the HTTP date. So you will get it through the practice, okay? But for now, just take it as granted. I'm making it as timestamp. Okay. Nothing wrong here. It is not highlighted. Okay. This is fine. Oh, this is the brace. Space, and then percentile. This brace is not required actually. They just made it. Let me keep this brace out here. So this brace is unnecessary. We have to remove this from our Nginx configuration. Systemctl stop Nginx vim /etc/nginx nginx.conf. So this is the unnecessary brace that is giving problems. Okay. Systemctl restart Nginx. Just check var log Nginx access.log. Let me generate. Okay, now there is no brace. Let me take this one. Okay. So now you can see this timestamp and then space and this get. What is the word for that? The name itself is word. Okay, so this is the one you have to copy. And then space. This is the URL pattern. Okay, for that, this one, the same thing. URI path param. This can work. Dollar. This word is working, and this one, let me take this. So this is method, and this entire thing is URI path param. So percentile, and let me find something here. URI host, URI path. URI host, or URI query. Okay, URI query, it is detected, and space, no, URI query. This is nothing but I'm making it as path. Okay, so this is the URI query, and then space percentile, and then this one. And what is this? HTTP not date. Just let me check URI. No. This is path, and this is the status, and this is the duration. Just I'm finding this one. This log stash. So this one HTTP version. Okay, let me take space percentile. HTTP version is not there. Okay. Let me proceed. Percentile, and then status. What is the word for status? Let me check here. So this is little tricky generally. Once you write that, then that's it. HTTP. You can have it as number. You don't find anything. Colon HTTP status. It's not highlighted. Okay. Fine. And then percentile. So like this. Again, it is number. And then you can just have duration. So by default, it is string format. You need to give it as different format, just like you can check here. So there will be so generally if the duration is a number, it may by default it is in string format. If you want to convert into different format, you just need to use either int or float. If it is points, then we need to use float only. Float. But only thing is this is not highlighted. HTTP file. Okay, so HTTP address is the format here, space. This log file is nothing but request. Anything here we can find? HTTP version. Filter. HTTP version filter log stash. This is just one thing that is request. So for now, what I do is I will remove this. Okay, later tomorrow I'll find out what is it. I'm removing this for now. Just posting status and time. Remove this. From here, let me remove this one. So this is the format we get. And this is the we'll get time and then we'll get status. That's it. Okay, we are not getting this one. And this is space percentile. And then this is number. You can just give it as HTTP status. And then you can just give it as int space percentile and this one. And this is number again. You can just give it as duration colon float. Is this not selected? Space percentile. And this is number duration. Yeah, this is fine. And I need to just give it as float. Yeah, this is the format, final format we need to filter in the log stash. Okay, so we have to just replace this with our pattern. So this is the pattern. Generally, it is typical. While writing this format, generally it is typical. You need to spend some time on it. But for now, I know few fields. I don't know few fields. That's why I just struggled it, but it's fine. I will find it later. Don't want to waste some time here. So this is the filter you need to add inside the configuration of Logstash. Just go here in ELK. First, I'm stopping this. Stop Logstash. I'm restarting this. Stopping this Nginx also. So here, let me open the etc Logstash and then default. cd etc Logstash folder. And then here we have conf.t. From here we have logstash.conf. So here it is a filter. Okay. So this is the filter we have to give. So that's it. We replaced with our pattern. This is the pattern we replaced. Okay. And save this. Okay. Now we can start Logstash. Systemctl start Logstash and then systemctl start Nginx, systemctl restart filebit. Okay. All the components are started. Now let us go into the website and generate some traffic. Just browsing simply. And now you can just see the traffic here. Refresh. Now is the latest. Data. So just check this Logstash is sending the data or not. Where log messages. Let's just check it. It should generate something. Yeah, it is sending. So now Logstash filter. Now let me refresh. So filebit is sending to Logstash. Now we need to check the Logstash logs. Where Logstash. So here Logstash json.log. Logstash plain.log. So it is saying successfully started Logstash API endpoint. And then at the end, it is some exception. Object mapping for client, tried to a parse fill client as object, but found a concrete value. So there is some exception here. Okay, something wrong we have done. This is correct. This is the error. Just search this. IP is correct. This client mapping for client, tried to parse a field, but client as object, found a concrete value. This is the pattern. Let me check our Nginx log. Daily var log Nginx access.log. So this is the IP address. This is the timestamp. This is the timestamp till here, and this is the status code, and this is the duration. 1, 2, 3, 2, 3, 4 fields. 1, 2, 3, 4 fields. Correct. And let me find some patterns. Log stash sample filter for Nginx. Logstash.conf. There is no filter. Okay. Proc pattern for Nginx. He's not logging IP address. He's logging timestamp. And this one. Yeah, this is the Nginx format. This is the timestamp. This is the exact thing, whatever we are getting. So for this is the pattern, actually, full pattern. Okay, anyhow, we can do this tomorrow. Okay, for now today. So what are the things you can do? Logstash we can repeat again. This is a little bit complex component, but we use it for this purpose only. So today you will install ELK and then send the logs through FileBeat to the Elasticsearch for the first time, and the second time send the logs from FileBeat to Logstash and then output. Okay, so this filters we'll discuss more in tomorrow's session. Okay. This is the reference we got. Okay, we can add one more. If you are able to do, you can just try this today. Just add one more pattern at the end. Oh, IP or host. So add just one more pattern at the end, duration. That's it. Okay. Yeah. Any questions? Yes, Suresh P.
Hello.
Yeah, hi.
Yeah, hi.
Yes, please.
No.
Okay, thank you. Sudhir Pagadala.
Hi, Shiva.
Yeah,
Thank you.
hi.
Shiva, so we have explored the ELK, but are we going to explore any Prometheus and Grafana as well?
Yes.
Okay. So these two are the similar category, right?
Prometheus and Grafana, they are for metrics export.
Metrics export.
So these are like log files export.
So in that case, can we say ELK and Splunk are in the same category?
Splunk generally for security also. So we Splunk, there are a lot of other usages also. It's an enterprise heavy tool, generally used for security purpose. Okay, you can do the security monitoring through the logs also. You can understand a frequent IP address within few minutes if it is sending millions of requests. So then you can understand someone is trying to hack our system. So that can be detected, yeah, through the Splunk as well. Yeah, it is just like ELK and it has more features.
Okay,
but ELK is for the searching purpose originally. So originally ELK is invented for the search purpose, like this automatic search results, right? So whatever I'm just typing here. So this is for the ELK is for the search purpose, but later it is used for log monitoring as well. Log monitoring and searching purpose. If you want some security related things, then you can go for Splunk. Splunk is mostly for the security purpose. You can understand some security threats.
understood.
Yeah. Okay.
Thank you.
Yes, so today is a bit heavy session, but you forget about Logstash today while practice. Just do this part. Okay, forget about Logstash filters. Tomorrow we can explore more on this regex patterns. Okay. Yeah. So if no more questions, we can end the session. Have a nice day. Thank you. Bye bye. See you.